Hello, welcome to this third part of this lesson where we will learn about gradient cash flow analysis. And the first two parts we already covered the series of cash flow, the generic way, random way of having cash flows, and the uniform series cash flow. In this part, we'll learn how to analyze gradient series cash flows. Gradient series happen when a cash flow is greater than the previous one. So when you have a series and your value in that series increases linearly. So we start here with a value g, and then you start adding g value over time. This is how it will look like, and this is how it's mathematically modeled in the formulas we'll see. One thing to pay attention to is the first year of the series will have a zero cash flow. This is how it's again represented in formulas we will deal with. So zero, this year one is part of the series, even if it has no cash flow for it. And the first non-zero cash flow will be at the end of the second year of the series. So we can represent that for the series here, a value of it will equal to, if it's the first year, it's equal to 0. And if it's any other year, it will be more than the previous year by the gradient value g. So this is the formula for calculating the present of such a series. So if I have that series with, that shape here, if I want to calculate the present, I will multiply it by this formula, or this formula I can represent it with a factor p given g. This p given g is another column in the standard interest columns, interest tables. P given g, every page is an interest rate, and the rows here are the number n, which is, remember, n here is if you see here there are 1, 2, 3, 4 arrows, but for us here n is actually 5, because don't forget the 0 arrow, kind of 0 value here for the first year of the series. So like we be able to calculate the present worth, I will be able to calculate, which is something new to us, calculating the annual worth or the uniform series worth of this gradient series. So I can kind of melt this value over the years, and we'll end up with an equal value equivalent to that triangular linear increasing cash flow. So this A value, I can calculate it for a G cash flow with this formula, or with this factor A given G. You can guess it, this factor is another column in the tables. So I cover P given G, I cover also A given G. I can also calculate the future worth of a gradient series using this formula. And this formula, if I call it like all the other times I summarize or called formulas with a factor, so this factor will be F given G factor. Now the issue here, there is no F given G factor provided by the tables. So kind of we're stuck. There are problems that will have a gradient series, and I want to calculate the future for it. I have no factor available, so what suggestions you can think of? So think about it. What is available to us? I have P given G and I have A given G. Can I use these factors to figure out F given G? The answer is yes. I can actually use the factors given to us to figure out, or kind of invent, you can say, a third vector of F given G. So if I use P given G, this means I'm calculating the present worth of a gradient series. It's not the future, what I'm looking for, but I can bring that present to the future through an F given P factor. So I multiply these two factors. Similarly, I can calculate the annual worth or the uniform series worth of the gradient A given G. It's not what I want the future. So I can bring the future of the annual by multiplying by F given A. Either way will give you the same value. So try it out for an example and you'll find actually both approaches give you the same answer. Now let's see an example of gradient series. And one thing you will notice that gradient series they are the unidentical twin of a uniform series. They always come together in a problem. So you will have a problem that the cash flow you can represent it by a uniform series and gradient series coming together. So let's see this example here. Maintenance costs for a machine, it increases by $1,000 over 5 years. The initial maintenance cost, however, was $3,000. Using a time value of money or interest rate here of 8%, determine the present worth equivalent for this maintenance cost. So this is the cash flow. I start with this initial maintenance, $3,000, and every year I increase by $1,000. So I increase by a fixed amount, so it's a linear series. But if you remember the gradient series, by definition, the first year should have a zero cash flow. So what will happen is I will break this cash flow down into two cash flows. One is a uniform series of 3,000, and then the other one will be a gradient series of 1,000. And remember, this year here has zero cash flow, but it is part of this year's, all right? And they together will add up to the original cash flow. So if you're an engineer and mechanical or civil, you studied statics and strength of materials, you learn about superposition method. So this is exactly it. I'm using the superposition to break down, divide and conquer a cash flow into the two cash flows I can actually deal with their factors. And when I add their present worth values, I will end up with the present worth of the original cash flow. So this is exactly what happens. The present worth of the original cash flow will equal to the present worth of the first component cash flow, and the second component cash flow. So the first one, P1, is equal to the present worth of A, so it's multiplying the 3,000 times P given A. And then the P2 is the present worth of the gradient, and it's P given G times 1,000. Now, one thing also to pay attention to, that the present worth here is calculated, of a series is calculated at the beginning of the first year. Uniform series, the first arrow, first year is this, I'm calculating it where I want it. The gradient series, the first year is, don't forget, this one, even if it doesn't have an arrow. So I'm calculating at the beginning of it, it matches with this one. When I add them together, they add up to the present worth of the original cash flow. So this is the calculations, get the factors from the tables or the formulas, and you will end up with this value here as a present worth of this cash flow. There is another way, which is translating that gradient into a uniform cash flow. So I will call it here A prime, and then add the A prime, because now this A prime is a 5-year cash flow. I can add it actually to this one. So a 5-year series with a 5-year series matching together, I can add them and then multiply the resultant of them with the factor P given A, so bring it to the present. Remember, I want the present of the original cash flow. So A prime, this is an example of using, instead of P given G, I'm using now A given G. So it's negative 3,000 as a times 1, because I'm calculating for this bigger parentheses. It's a uniform series, so it is already a uniform series over 5 years. This one is a gradient that's transformed into a uniform series. I add them together, times P given A, get the values for the factors, and you end up with the same answer. In engineering economics, you can analyze the cash flow in many, many ways. So I'm just giving here 2 possible ways, considering that gradient can be calculated the present worth for it by just directly P given G, or A given G and then multiply P given A. So let's see a second example here. Amanda here made 5 annual deposits into a fund that gives an interest rate of 8%. Her first deposit with $800, and each successive deposit of the 5 deposits is decreasing by $100. So how much will be in the fund immediately after the 5th deposit, which is, we're asking for the future worth. So if I show here the cash flow, So remember, it started with depositing 800, and then the deposits, or the amount she deposits, started to decrease by $100. So the next year 700, and you keep going down like that, decreasing. And the objective here is to calculate the future worth. And I can see, like similar to the previous example, I can see like you expect gradient cash flow to come kind of like a twin with a uniform series. So I will say I have a uniform series times FA, F given A, and I have 5 years series and 8%. And G will be kind of probably matching with that, 5 years and 8%. I'm using year factor F given G. The question here is, what's really A and what's really G? So if someone, let's say, I will split the cash flow into components like that. So my A is equal to negative 400, and G will be negative 100. So I'm decreasing by 100. This is incorrect. So remember, the first cash flow of G must be equal to 0. And this is not the case here, because if you broke down 400 here out of the original cash flow, what I'm left for that represents G, the first part of it, or the first payment of it, will be 400, because I took out 400 from 800. That's not a zero cash flow. That's not, it's kind of a triangle. So my starting, the triangle should be the other way. Actually, the head of the triangle should be here, and it increases like that. That's not the case here. So that's not the right way. It's not the right way to break down this cash flow. So the right way to break down this cash flow is actually put A equal to negative 800, and then G will be positive 100. I know it might be a little confusing, but let's visualize it more. So this will be the gradient, and I'm actually deducting from this negative series cash flow of negative 800. I'm adding to it 100 every year. So that will be kind of the cash flows. If I break them down, I will have a negative 800 uniform series, and then a positive gradient of 100. If you add up these values, just try it in your own time, you will end up with the original cash flow. So future worth will equal to, plug in now A and G with the factors. One thing you will notice that if given G is not in the tables, right? I can use the formulas, but for me, I like to use the tables, already the values calculated for us. So remember, F given G, there are 2 ways of calculating it. So I will use one way, which is A given G times F given A. So A given G times F given A. And now I have 3 factors to figure out from the tables, kind of got the values from the tables, and this is the future worth of this cash flow. Remember, this is one way. Maybe try at your own time, instead of A given G times F given A, try P given G times F given P. So that will be kind of a fun exercise for you to do. All right, so geometric series is something we will cover later in the next video. So that was a slide by mistake here, but we'll skip that. And this gradient series here is not covered yet, but we will see it next lecture. So geometric series is not covered. So we covered the gradient series, uniform series, and the gradient series. We'll cover next lecture geometric series. All right, thank you so much. I will see you in the last part of this lesson. Take care.